Hello, my name is Kurt Risley. I teach at City High Middle School here in Grand Rapids, Michigan. I teach seventh grade Earth and Physical Science, and I also teach a DPIB uh, Environmental Systems and Societies course. And the lesson that I'm going to share with you today is really geared towards the middle school grade band, grades 6 through 8. And the objectives for today, our students are going to form some relationships between latitude and annual average temperature, relationships between elevation and annual average temperature, and then how does proximity to water influence average annual temperature range. And lastly, they're going to be creating their own model to illustrate their understanding. I will let you read the performance expectations later, but I'm going to kind of go through the lesson using some Google Slides here. So, as an Engage, I thought it would be an easy connection for kids to um, connect with our unique weather and climate here in the state of Michigan. Students should know the difference at this point between weather and climate. If they don't, as all good teachers do, they're going to know this information. Pre-assessing kids, pre-teaching this, and to have them ready for this. But essentially, regardless if they know the difference, they're going to know that we have some unique weather and climate here in Michigan. And essentially, what they're going to do is just identify ways that our unique weather and climate both help and hinder our economy. And so be creative with this, share it out any way that you want, using any type of strategies that you have, but have fun with it. And lastly, I've created um, some additional ideas to kind of have fun with this. And so don't be afraid to just let students explore, or you can do teacher-led discussion around some fun things that have happened in Michigan, like the blizzard of 78, the sinking of the Edmund Fitzgerald. And last but not least, something that I find students of all ages are very surprised to learn about is the economic impact that our agricultural sector has here in our state. And so, highlighting some of the unique things that we have going on in our state agriculturally. And so, this is just a way to get kids thinking about ways that our climate is unique here in Michigan. And we'll end with our evaluate, focusing here on our state. So, the bulk of the lesson is going to be focused on the Explorer. And before I show you that document, just a couple side notes. Please be prepared to read through this, understand it. I will give a teacher copy with some answers, so you don't have to look for all of them. But please read through those. Also, I do have a map on this, but if you're doing it digitally, you might not want to have students plot all of these on the map. You don't need to, but just to be prepared for that. So I'm going to show you the document itself, and the climate exploration is pretty pretty sequential. And so if they read through it, it's pretty self-guided. And so first, it's just asking students to make a hypothesis. A lot of students are going to already know the relationship between latitude and average annual temperature, which is fine because they're still practicing the skill set of claim evidence and reasoning. And so what they're going to be doing is collecting their own data. I would encourage students to use this site. I've used it to make the teacher document. Seems to work pretty well. And a couple things of note there, just to address some questions you'll have from students. Some of these locations, Seattle, Miami, big cities, they're going to have multiple weather stations, and so it doesn't really matter which one students pick. The data will speak pretty loudly, as we have locations ranging from the Tropic of Cancer, almost Miami, Florida, all the way up to almost the Arctic Circle in Yellowknife, Canada. So the data will speak pretty loudly. When the students are done, they're really referencing their hypothesis. So making a claim, do they have the right understanding of the relationship between latitude and average temperature, average yearly temperature? And then using two pieces of data to provide justification for their claim, right? And then lastly, just making a very, very concrete claim about the relationship here. The next one they're going to be going through is the range in temperature. So these locations here have been thought through to isolate this variable. And so a lot of these are going to be the same latitude. So, for instance, San Francisco and St. Louis, Seattle, and Minot, North Dakota. And what they're going to be doing is looking at the highest monthly average and the lowest monthly average and finding the difference between the two, or the range in temperature. And so, you can look at this with the teacher data, but the locations with the highest range in data are going to be the locations in the center of the country. So Minot, North Dakota and St. Louis, Missouri on that chart should have the largest temperature ranges. And the same latitude, places like San Francisco, I believe it's like 11 degrees annual average range. It was very small. So the weather, or excuse me, the climate is very similar there year round. Same with Seattle. And again, doing kind of the same thing, using the evidence to support their positions. And the last but not least, they're going to be using elevation to be making a claim of how does elevation relate to average annual temperature, right? And this is pretty scaffolded, where they're actually ranking them out, and these are also pretty similar latitude, and so these can be used to make that relationship. Again, students can plot these or not plot them. That is going to be up to you. So once students are done with that, it's really up to you as an awesome teacher to find what you think would work best for the explain. Okay, so a couple things that I want to make sure I communicate clearly. And the explain portion of this is to make sure we have a laser focus on claim, evidence, and reasoning. Are students using the right evidence to support the relationships that as latitude increases, average yearly temperature decreases? We're not talking about explaining the science behind this at this point. So you shouldn't be like, explaining the role of specific heat capacity and adiabatic cooling. Like, this is not part of this explanation. This is really focusing on, are students able to accurately understand these relationships using the data that they have collected. After that's done, the students have kind of a fun activity where they're going to be creating their own model and using their own model to not only extend their learning, which is a really, really difficult thing, especially for this age group, but can also be used as an evaluate. And I'll talk about that a little bit. So essentially, I'll kind of model this in a, which will be interesting. But so essentially, what they're going to do is they're just going to create a Michigan mitten, okay? And what they're going to do is they're going to start layering on this information. So the kind of the thinking is, through our work with the MiRCLE, we have been looking at a lot of data layering over maps, and so this is kind of the same idea, just as in a very elementary fashion. So essentially, they're going to be layering on the coldest region of the state based on latitude. And so I thought I would try to model this here. And so this can be, you can do this digitally or by hand, but essentially, I'm just going to chicken scratch this, but they're just going to make a model of Michigan here. So it doesn't have to be like super, nice and neat or anything. I would probably give kids just like 2 minutes, make it fun. You can even have competition or something. But the first thing they're going to do is just make a key. So I'm just going to do, this color, and that's going to equal latitude. Okay. And so again, the question that's posed in the slides is to highlight a region of the state that I think is going to be the coldest based on latitude. So students, hopefully, they might not at this point, because transferring is difficult. They're hopefully going to say, okay, the coldest are going to be places with high latitude. And so they might do something like this, right? At this point, I would share out. And so we're going to share out depending on the environment you have in your class. You can do some like pushback, things like that. And then the next slide is essentially going to be doing the same thing, which is going to be focusing on where would the coldest locations be in the state based on proximity to water. Now, before I draw this out, something that's a scaffold that students might need for this is they might need to look at climagraphs to be able to see. Here's a climograph. Kind of these higher temperatures, places with high range are going to have high temperatures in the summer, but also extremely cold temperatures in the winter, whereas San Francisco might look something like that. Okay. So I'm going to just make another color here. Hopefully you can see the difference. It's purple. And we're going to do this proximity. Okay. And so I'm just going to basically really quickly just highlight an area that I think is going to be the coldest. So I've had students do, like around the water. I saw that. I also, hopefully we'll have some of this where people will, do the center of the state, something like that. All right. And the next slide is going to be pick the coldest location. I'll make this one stand out. So the coldest location. Okay, so we'll just say lowest. Okay, so what is the absolute lowest location or lowest temperature, excuse me. And so I'm going to actually put this here. Okay. All right. So again, after each one of these, I would have students actually share this out and share their thinking. And depending on the classroom environment that you have, push back on each other's thinking. Feel free to, or it's encouraged to use the data that we just gathered. But that's really the idea behind creating this model. And hopefully theirs look way better than mine. All right. So once they get through all of that, the last part, which can be used for an evaluate phase of a lesson, or it cannot be. It's up to you. Is to check in. So, were you correct on your location? So, this Michigan hardiness zone map does reveal that north central part of the state is the coldest average annual temperature. So basically, what they're asked to do is explain why that is. And again, this is not focused on the science behind this. It's focused on that they're understanding the relationships. So they need to be using latitude and proximity to water in their answer. And if they can say that it's high latitude and it's farther from water, so it's going to have a larger temperature range, making it colder, they got it. All right. And then lastly, you could easily just add on the tag of based on what you know about elevation, would you expect this location to have a low or high elevation and why? So that's one evaluate. If you're feeling like you're getting to this point and students aren't ready, you could always easily make some slides and chunk each one out and give two extremes like Northern Canada, Miami, Florida, like which one's going to have a warmer or colder average temperature and why, and chunk each one out. That's definitely a possibility as well. But if students do this, they should be able to show their understanding just fine. All right. So the next thing I want to do is just kind of talk a little bit about, well, where can students go from here? All right. So this is what I would think that I would probably be doing after this. There are some performance expectations about water's ability to moderate climate on our planet. And so I would probably take this another step farther and let students develop their own investigations to analyze a really broad question, which is what influences a material's ability to heat and cool. And so students can ask all different types of questions like, does the amount of the material matter? Does the type of material matter? right? So like hopefully some kids will be thinking about like sand versus water. Let's see. Um, does the color of the material, that would be a good one students could do. And so I would have students create this investigation, use temperature probes, and actually go in and analyze their data. And lastly, I would finish off by creating a poster board that would have their question, right? So for example, does the volume of the material influence its ability to heat and cool? Okay, and then they would make on the sticky note, put it in the yes or no column, and then put their data that supports it. Right, students can do a gallery walk, and you could essentially mimic the climate exploration and have the students answer the questions using the data that's on the poster board. So I think that would be a really good way to kind of extend this lesson into another way to be analyzing data and getting kids to have fun and create their own labs. So I hope you enjoy, and I hope you enjoy looking at the lesson plan. And thank you for all of your work.